Hi, I'm Mr. Huber, and in this video we're going to talk about the factored form. Well, in the last video we looked at the benefits of the factored form. Well, you can more or less read the zeros of the factored form directly, because you see it's a plus 3, and in order to make this 0 you have to plug in minus 3, and you can plug in 5 in order to make this 0, and you have the second 0. So one 0 is at minus 3, the other one is at 5. And it's so beneficial because the vertex must lie in between these two, right in between these two zeros. And it's easy to work out the y-intercept as well. So it would be great if we were able to go from here to here. Okay? From the general form to the factored form. Because the factored form is almost as practical as the vertex form, because we have quite a few pieces of information right from the start. Okay, so let's start with a simple example. So let's say x plus 2 times x plus 8. Let's work out the general form and see what happens. X squared, so this times this, plus 8x plus 2x plus 2 times 8, 16. Now let's simplify this, and we get x squared plus 10x plus 16. So what do we notice? This number is made up by the product of these two. So it's 2 times 8. 2 times 8 is 16. And this number is in fact the sum of the two. 2 plus 8. Okay. So that's quite interesting. Let's look at another example. X plus, let's say, 5 and x plus 7. So here again, you have to keep these things in mind. You have to see a pattern. So this is now x squared, this times this, and this times this, plus 7x. This times this plus 5x, and this times this is 35. Now let's simplify this, and x squared plus 12x plus 35. So this is in fact 5 times 7, and this is 5 plus 7. So it seems to work. It's quite clear. So you could do it in general. X plus a, x plus b. Well, this would lead to x squared plus b times x plus a times x plus a times b. So let's simplify this, and we're going to get x squared plus a plus b times x plus ab. So what we can see is that this middle term here is always the sum of the two, and this term at the back is always the multiplication of the two. So let's see whether that was the case in our introductory example. Well, look here, same thing, but we have one that's positive, the other that's negative. So 3 plus minus 5, that's minus 2. And 3 times minus 5, that's minus 15. So it worked there too. And now let's have a look at how we could get back from here to here. Let's say we get f of x is x squared plus 10x plus 16. So the unfortunate thing is that it's not always possible to write it in factored form when we work with real mathematics, okay? When you work with complex mathematics, it might be possible, or it will be possible. But here, in our case, like not every function has zeros, not every quadratic has zeros. It's the same thing here. Now look, how could we go back? We could say, well, 16 has to be made up by the product of two numbers. So it could be 1 times 16. It could be 2 times 8. It cannot be 3 times something. Well, in fact, we're only looking for integer solutions, okay? So 1, 2, 3, 4, minus 1, 2, minus 1, minus 2, minus 3, and so on. Okay, only integer solutions. If the solutions are not integer solutions, then we will use another method later on. So 3 times something is not possible with integer numbers, but 4 times 4 would be possible. Well, then you could say, well, it could be 8 times 2, and then it could be 16 times 2. But well, you see, these are not interesting because it's the same thing as the first two, just reversed. So now we know there are 3 possibilities with integer numbers to get to 16. And you know that this one is the sum of these two numbers. So let's see. 1 plus 16, that's 17. That doesn't work. 2 plus 8, 10. That seems to work. So what you then are going to do is you're going to say x plus 2 and x plus 8. And that will work. And it's a self-correcting exercise because you could always just calculate this and expand it, and you would get this. Okay. So the next one we had before was f of x squared plus 12x plus 35. So here it's the same thing. You say, well, 35 can be made by multiplying 1 times 35. 2 times, not an integer number. 3 times, not possible. 4 times, not possible. 5 times 7. And then it will be 7 times 5, so not needed, okay? So it has to be one of these two pairs, okay? Either it's 1 times 35 or 5 times 7. Now look, when you add them up, you know this has to be it. Because look, f of x is x plus 5 and x plus 7. Because the multiplication of the two is always 35, but then it has to satisfy a second condition, which is in fact 5 plus 7 has to be 12. And let's see whether it could work with the introductory example from the last video. Well, here, you know, 15 can be made up by 3 times 5 or 1 times 15. But, well, you have a minus here. So one of the two has to be negative, okay? One of the two. Either it's minus 1 times 15, or it's 1 times minus 15. Or it's minus 3 times 5, or 3 times minus 5. And then, you know, when you add them up, you have to get to 2. And you can see the only pair that satisfies that is 3 and minus 5. 3 times minus 5 is minus 15, that's correct. And 3 plus minus 5 is minus 2. So what do? You do the following, and you say x plus 3, x minus 5. Because 3 times minus 5 is minus 15. 3 plus minus 5 is minus 2. And this is how we get back to this form. And we can use all the benefits from the form now. How we get back from this to this form, obviously. So let's try that in the first exercise, and I'll see you in the next one.